Hey everybody, today we are going to take a look at another way that we have been able to show that triangles are congruent, and that is using the angle side angle triangle congruence theorem. And we're going to be able to explain how that works today and then use that theorem in a proof. Before we get started though, we want to take a look at this figure and have a couple of questions. What are three things that you notice? And what's something that you might wonder about? Some things you may notice are that it's about lines. Obviously, there's a couple of lines there. And that these two lines, L and M, are actually intersecting. And they intersect at a point that's called Q and P. It has both names. Probably Q is from one of the lines, maybe M, and P is from the line L, and Q and P just happen to be at the same spot, and that is where the two lines intersect. The other possibility is that the lines could be parallel, and maybe you're wondering, why are we looking at intersecting lines and parallel lines and all that? Okay, we're proving the angle side angle triangle congruence theorem, and to be exact, we're really not proving it here, guys. We're just showing that, in fact, it does work. And the first thing we're going to be doing is taking these two triangles, WXY, DEF, and we want to use the angle and label tools to verify that W is congruent to D, and angle X is congruent to angle E, and also that side WX is congruent to side DE, so that we're getting that angle side angle concept. So let's go ahead and find those angle measures. And then determine the length of the segment between D and E by labeling it. And we notice that yes, indeed, they are exactly the same. Then going to the next step, we want to use a sequence of rigid motions to take WXY onto DEF. And then for each of them, you're going to explain down in this little window, like we always do, what you're doing and how you know that one or more of those vertices is going to line up. Now in this first step, what I did is I translated W over to D using that directed ray of WD, and then we're going to look at this and say, hey, wait a minute, we've got a space here, what can we do? So we're going to have to close the gap between these two, and we do that by figuring out what the gap is using our angle tool. And we see, oh, it's 16 degrees. So I'm going to do another transformation, a rotation, where we're going to rotate this triangle here. It would be W prime, Y prime, X prime. And we're going to rotate that with D as the center. And we're going to rotate it 16 degrees. Notice now that the two triangles are lined up along this line of reflection that we've been looking at yesterday, and we see that DE is now a line of reflection, and we can just reflect our triangle over this line DE. So the third transformation will be a reflection, and we're going to pick the center of that triangle and then flip it over and see that it actually does line up. So we can make WYX line up with DFE. Now here is something kind of interesting. We want to reflect DEY prime over DE. Before I do that, how should it line up? Okay, here we go. Could the situation look like this after we reflect across DE? What do you think? And how do you know? Should it do this? And the answer is no, it shouldn't. And it shouldn't because we know that DE, when we do the reflection, DE is that perpendicular bisector between F and Y prime, and that these two would actually be the reflection of each other. So that's why it really doesn't work this way. It could work in doing something else, but not a reflection. Okay, next let's take a look at some parallel lines. Before we said that lines can either intersect like they do here, L and M are intersecting with this line transversal, and we see that L is parallel to M. When that happens, what do we know about these angle measures on all these angles that are being formed? We know they have special names. Today we're looking at the angle measures, and I want you to go ahead and complete this table. I'm going to pause the video and complete it myself, and then you complete it while I've got this paused, and let's see if we get the same values. Okay, let's take a look at this. So we see that with the transversal, there are 4 angles that are formed here at line L and 4 more at line M. We see that A is 42 degrees, and so that means the vertical angle, vertical pair, so we talked about yesterday, A and C should both be 42 degrees, and then also E, because A and E are corresponding angles, those should be 42. And then A and G should also be 42 because those are alternate exterior angles. Then all the other angles should be 138 degrees because they will form linear pairs with the other angles that are listed already. So hopefully you get that table correct, and we're going to be looking at more of that in class today. So lesson synthesis, we want to brainstorm a list of hints or steps that can be helpful when we're writing proofs that use triangle congruence theorems. And here's a list of those that you may have thought about or seen before: adding auxiliary lines, looking for congruent triangles, needing the correct 3 pieces of information about the triangle and looking for those 3 pieces, using the marks on the diagrams and the given information, using other information like angles formed by parallel lines, or using congruent triangles to prove that other pairs of corresponding segments or angles are congruent.